So as he said, I'm Anthony. I do site reliability at fleetio.com. And today I'm going to talk about kind of how to get started with the Rails app and site reliability and how to make sense of some of the things that you see, because there's a lot there and it's complicated and it doesn't always make sense when you look at it. So we're going to try to make a little bit of sense out of it, so as you begin to work on the reliability of your sites, you'll maybe be able to be a little more productive. In the beginning, a developer generated the app in the schema. And the app was without form and void, and opaqueness was upon execution of the app. Rails apps really kind of all start out the same way, right? Like Twitter, for instance. GitHub. Even Fleetio. I did not run that command, but somebody did. And when they start, there's not a whole lot there, right? They're kind of empty, but there is this happy little site. I mean, that's a happy site if you ever saw one, right? It actually performs really, really well. It's quite reliable. In fact, it's probably the most reliable this site is ever going to be. Frankly, it's all downhill from here, right? This is it. Because the very next thing that happens is this. Complexity on top of complexity on top of complexity. And in the beginning of the app, our focus is on financial viability. We're trying to create something that somebody wants, and they want it bad enough to give us some money. And at that time, that's more important than the reliability of the app. And as we begin to build out the functionality and people begin to buy our app and they'll begin to use it, we begin to add more functionality to satisfy their needs, there comes a point where site reliability begins to equal financial viability. There comes a point where they're like, I can't use this thing if it doesn't work. I can't use it if it's too slow. I can't use it if it's broken. But by the time we get to this point, we've got a web UI, we've got mobile apps, we've got APIs, databases, Elasticsearch, Redis, background jobs, AWS services, gems galore. I mean, a list of gems a mile long. We've got third-party services. Sometimes they function fast, sometimes they don't. We're sending emails, we're sending text messages. Ben, I hope that's not a problem with yours. But those things can be slow too. We have to figure out what is going on. But there's a problem. There's this opaqueness we can't see, especially in production, right? We put all this stuff in the cloud and we've created the Cloud of Unknowing. I think it's pretty awesome that the name of this title for a book came from an anonymous 14th century mystic, and it's a great explanation of the problem that we run into as we get to the place where reliability becomes a problem. And the developer said, let there be metrics. And there was visibility, and the developer saw the metrics, that they were good, and the metrics divided the reliable from the unreliable. And the developer called the reliable quality, and the unreliable he called defects. And the integration and the deployment were the first iteration. Where do we get these metrics from, right? I mean, I do not recommend that when you first start having reliability problems that you go and build your own metric system. Please don't do that. Instead, do this. Install one of these guys, right? Especially that one in the middle. I think he's a sponsor of our conference today. Go and install some of these guys, and they will begin to give you the visibility that you need. At this point, when we install something like this, we begin to be able to see things that we couldn't see before. We begin to be able to understand some things. Over time, this has become my favorite piece of advice to give to software developers. Out of all the advice that I could give you, this is my favorite piece. To understand is hard. But once one understands, action is easy. It's the understanding that's important. And for us to take a site that has become really complex and begin to make it more reliable, we've got to understand what is actually going on. Because if we don't, we can do all kinds of things. I've been in these conversations before. Well, I think it's this. Or I think it's that. I bet you it's this. I'll tell you what, we'll try that and see what happens. No, don't do that. Get understanding. And when you get understanding, then act. This is the place to begin. As soon as reliability becomes a problem, the very next iteration needs to be deploying metrics to the system. Now, when we're talking about the reliability of our application, we're thinking about service levels. And oftentimes we're familiar with this idea of an SLA, a service level agreement. But SLAs are really built on some other building blocks. The first one is a service level indicator. These are the actual metrics that we're recording. We're recording how fast a response was. We're recording what the availability of our site is. These are the things that indicate what level of service we actually have right now. Then there are service level objectives. When we're saying something about what we want those metrics to be, it's something like we want our 95th percentile request time to be less than 2 seconds. It's something like we want the availability of our application to be greater than 99.9%. Now, once we have these measurements and we have these objectives, then we can build on top of that a service level agreement, and that agreement is a contractual agreement with our customers. And usually it's just a couple of things like availability and something about AppDex, something along those lines. But the SLOs are very important tools for us to use internally. We can define as many of those as we want. Contractually, we don't want any more SLAs than we have to agree to get in the business, right? But as professionals, we can create as many objectives as we want. We can define our service in a way that gives the kind of quality that we want it to have. So I highly recommend, as you get these metrics, begin thinking about what they should be, what the objectives for each one should be, and begin to watch some of them. The first one is going to be availability. This is what our customers care about. Most of the time that's measured in some number of nines, 3, 4, 5 nines. 99.9% availability is pretty common. And oftentimes it's measured in a time-based fashion. There's a periodic ping of the site every minute, every 5 minutes. But this is not very satisfying to our customers. I mean, how many times have you had somebody say, your site has availability problems? You're like, no, look, it's 100% availability for the last 6 months. That's because we're pinging it every 5 minutes. And we only ping the login page or the one special page that we created just for pinging. And no customer ever uses. The customer is trying to do their job, and it's broke. So from their perspective, the site is unavailable. So a better way of measuring availability is request-based. Instead of saying that it's going to be up 99% of the time based on a ping, let's say that 99.9% of all requests to the service are going to be successful. Then, no matter which part of the service our customers are using, they're going to see a high level of availability. It's going to take into consideration partial outages. It's going to take into consideration that bug that I shipped this morning and then fixed a few minutes later, right? All that's going to show up in there. It gives us a view that is much more like what our customers expect. Now, if you're going to do site reliability, you're going to have to learn time travel. Because, I'll tell you, I was not awake at 4 a.m. in the morning when that happened. Somehow, I've got to go back in time to 4 a.m. in the morning and figure out what in the world happened. I've got to go back in time to see that. How do I do that? Actually, these APM tools allow us to do that sort of thing. And they do it in 2 ways. The first one is what we're going to call event streams, where it records something about each request. It records something about each asynchronous job. It records every exception. It records events that we add when we want to add things like a new customer signed up, an export was done, things of that sort. In those event streams, just at a point in time, this thing happened, and here's some information about it. Allow us to go back and recreate what happened at that time when that spike went up on that graph. The second way that we can travel back in time to see what's happening is through snapshots. Snapshots give us the ability to go back and see things that you can't put together by accumulating all of the events. I mean, it would be pretty awesome if you could record every memory allocation event in your system and then recreate the memory at some point in time. That's too many events. It doesn't make any sense. So what we do is every minute or so, we'll record what the memory is, CPU load, I/O, queue sizes, things of that sort. Here's an example of a situation where we use this idea, and this is such a powerful idea, this idea of snapshotting so we can go back in time and see what happened. So you can see here in the bottom right-hand corner, that graph shows our IOPS spiked above our limit. In the graph right above it, you can see our response time spiked accordingly, right? The thing about these kinds of spikes is that they're devilishly difficult to debug because when they happen, you can't go back to your slow query logs. You can't look at your APM tools at the queries because all the queries around that I/O spike that maxes out IOPS are slow. You can't see. It's just a blur of information. Postgres, and this was mentioned earlier by Craig, has pgstat statements where it records over time how many times a query is used and how much I/O it does. The problem is that you reset it at a point a week ago, and it's got a week's worth of stats. That happened a few hours ago, and I can't see it because it's all washed out in the stats over the last week. So what we did was we began snapshotting pgstat statements every 10 minutes and recording it and then clearing it. Every 10 minutes, record it, clear it, record it, clear it. Now what we can do, we can go back to that point in time where that 10-minute time frame was, and we will see exactly which queries caused that I/O spike. But we didn't lose the ability to look over time because now we can aggregate those, average them, sum them, and still be able to see what the accumulated queries are that produce a lot of I/O. So that's a very powerful tool, snapshotting. So now that we understand how to travel back in time, we know it's event streams and we know it's snapshots, we can think about how can we modify our event streams that we have so they're more useful. We can think about what kind of snapshots should we create so that we can see what we need to see to solve what we need to solve so that we can get the understanding in order to easily act on our problems. We're just going to talk about two aspects of site reliability today. We're going to talk about performance and we're going to talk about errors. There's a million things we could talk about, but we're going to focus on these two because when you get started, this is a good place to start. One of the things that we tend to care about is asynchronous jobs, and when you're looking at how fast things perform, jobs are a bit of a snowflake. Like with web requests, we can say something like, we want every web request to finish in less than 2 seconds at the 95th percentile. You can say that. You can't say that about jobs. Every job has a different duration. That's the whole reason why we take them out of the web request and put them in a job, because they don't fit that constraint. So when we're looking at the performance of a job, we have the wait time, how long it was queued before it started being processed, the service time, how long it took to process it, and then the response time, which is the total amount of time from when it was queued to when it was done. That's what our customers care about. Wait and service is really more about how we get the response time where it needs to be. When you have all three of these, you can graph them, you can look at them, you can see what's going on. You begin to figure out, is my problem a queuing time, is my problem a performance time? Another thing about jobs is that because they're snowflakes, each job needs its own SLO. Like with web requests, you can make one SLO that makes sense for every web request. For jobs, each job needs its own SLO. It needs its own objective for total response time. So then we can begin to measure them, see how they perform, and make sure that they act in a way that our customers will appreciate and feel like are performing. Other things to record is when the job is in queued, when it begins, when it succeeds, retries, or fails. In all of these scenarios, there needs to be attributes that let you know which job it is, what queue it's in. For retry and failure, be sure to record the reasons why. That's going to be critical when you're trying to figure out why this job is having problems. And when you've recorded all those, then you can graph them, you can watch what's happening, you can dig into those metrics and see why particular jobs are acting the way they are. And the last thing, use that snapshotting again. Snapshot the queue sizes every minute because it's hard to put together those graphs to show how big the queues actually are. So snapshotting them is a great way to do that. And these metrics that we're going to talk about here, they really apply to every kind of duration measurement. The wait times, the response times on the jobs, as well as the response times on web requests. The first one is the average. Watch out for averages. Those guys will lie to you. They'll make you feel good about yourself. They are flatterers. Only trust the bad ones. The good ones are lying to you. Maximums. With maximums, we need to beware, particularly with web requests, of outside causes. Because of that situation I mentioned a minute ago, there's this I/O spike over here on our database, and it causes this request to be slow. So watch out for that. Don't waste a lot of time trying to fix something that's not broken because the maximum is an outlier. But maximums do a really good job of being an early indicator of performance problems. They're like the canary in the tunnel, right? They will let you know really early on that this request had a really crazy time. Why was that? And as you're scaling your app and you're getting your first big customers, it's the maximums that will tell you where those big customers are seeing their problems. But percentiles are the bread and butter of your duration SLOs. Something like the 95th percentile or the 99th percentile. What those will do is it'll keep it from lying to you like the average, because it includes a lot of the bad ones, but it will also weed out some of those outliers that weren't really caused by this endpoint. If they were caused by this endpoint, then their percentiles would probably be higher. Here's an example. So every one of these, you'll notice all the averages are essentially the same. But that first one, its 95th percentile is 2.3 seconds. It's 2 seconds longer. So that tells you there's a problem there. But you'll notice on both of those, that second one is pretty good. It's still 0.6. But both of their maximums are the same. So what you're seeing there is that first one has a lot more closer to the maximum than the second one does. Look at that one on the bottom. That's crazy stuff. The 95th percentile is less than the average. How does that happen? I actually had to Google it. I was like, how does that work? How does it get to be less? And what happens is that really crazy outlier on the max pulls the average up above the 95th percentile. So when you see that big one there, you're like, okay, well, now we know it's one of two things, right? Either there's an outside cause, so I can look at my other metrics and go, was there an I/O spike at that time? If there was, okay, I'll ignore that. If there wasn't, then I may dig into it and look at the traces on that and see what's going on. Another nice metric is a time-consuming metric. So it takes our other durations and kind of figures out the percentage of time that a thing uses. And this is really great for understanding what the baseline load is on the system. So we can see here that there's a few endpoints that have a large percentage of all of the execution time that happens during the time frame that you're looking at. And when you work on those at the top, what you're doing is you can notice here that it's pretty high all the way across and there's one spike there. What you're trying to do is work on that baseline of load, bring it down so that when you do have spikes, they don't push you to the max. And as you lower that baseline, an interesting thing starts to happen. It's just like a stream. And there's this stream, and when it's full of water, there's no rocks. And when it's a dry spell and the stream gets low, all of a sudden there's rocks. And you're like, who put all these rocks in the stream? Nobody put the rocks in the stream. They was there the whole time. It's the same thing here. As you lower the baseline load, the spiky things start standing out, and then you can easily find them and fix them. AppDex is a metric that's talked about a lot and used, but seems like very few people actually understand what it does. It is a measurement of user satisfaction. What it tries to do is tell you what percentage of user interactions were satisfying to that user. It's calculated by defining a T, which is the target. Let's say we say that 1 second is a satisfying request time for a user, so anything less than that is satisfying. So we set our target to T. Anything less than T is satisfying to users. anything between T and 4T, so between 1 and 4 seconds, it's tolerating, they're okay with it. The closer it gets to 4T, the less okay they are with it. And when it crosses over 4T, now they're beginning to get frustrated. They're no longer happy with what we're giving them. This is calculated with a weighted average. Satisfying ones get a weight of 1, tolerating a weight of 0.5, and frustrated a weight of 0. So when it does the calculation, if we have 100 requests, 60 are satisfying, 30 are tolerating, and 10 are frustrating, when we're doing the average, we add all the satisfying ones, we add half of the tolerating ones, we don't add any of the frustrating ones, and then we divide it by the total of all of them, including the frustrating, and that tells us a percentage of the ones where the user was probably fairly happy. Now this is an interesting way of accumulating that data. You can use that AppDex and you can look at one endpoint and go, okay, this was pretty good. It's at 0.97. 97% of the customers were happy. 0.75, not so much. But one of the things that's hard to do sometimes is figuring out where to start. I mean, you got all this information, like what do I do first? What's the first thing I should fix? This is a really interesting one. What this is saying is that first one there accounts for 28% of all of the dissatisfying interactions with our product. That's a great place to start, right? Let's go there first. Yeah. So that's a really good way to use AppDex. Agony. Skylight was the first one that I heard of this metric from. A coworker of mine told me about it. Mine, I'm sure, is not near as sophisticated as theirs, but this is kind of the opposite way of looking at it. A measure of user dissatisfaction. And in some ways, it's the inverse of AppDex. So what we do here is we calculate a weighted sum. We flip the weights. Satisfied, get 0, tolerating 0.5, frustrated 1. And then in that same scenario, we have 10 frustrated, 30 tolerating. We get an agony score of 25. If you don't have all these pieces in your system, but you do have the ability to look at AppDex, you can do just 1 minus AppDex, invert it, times the total, and you get an agony score. It looks like this. So these are our top 7 most agonizing endpoints. So I think that's an instructive way to look at it as well. It helps us empathize with our users. We're causing this much pain to our users, right? So the first one there makes sense. It's got an AppDex of 0.7. You would think, yeah, I mean, that one's causing a lot of agony. Let's start there. You'll also notice that some of those on the list, the number 7 one and the number 4 one, have pretty good AppDexes. I mean, on that last one, 97% of the user's interactions are good, satisfying interactions. But it's in that time frame, it's used 54,000 times. Therefore, it's causing a good bit of agony. That's a good way to look at it and kind of decide where to start. One of the things that we tend to do is we tend to put in place timeouts as a measure of self-preservation. We're protecting ourselves from ourselves, right? Yeah, I've met the enemy and it's me. I'm DOSing my own site. But those timeouts are dangerous. Timeout durations are, by definition, unknown. We don't know how long they're going to take. We don't know when they're going to finish. We don't know how time-consuming they are. So they are a hiding place for extremely bad performance within our systems, and that's a good place to start. Go there and begin to fix those things. Slow queries. You know, the APM tools give us all kinds of ways to look at slow queries. There's a slow query logs in every database. Most databases will have stats, like we talked about already, the PG stat statements, and Craig mentioned those earlier. But the thing about looking at it this way, instead of looking at it as an endpoint or a job, is that it helps us see database performance problems that are related to cross-cutting concerns that you can't see when you just look at one endpoint, like permissions. Like, well, it only took a few milliseconds. It's not a big deal. But when you spread that across every request, a small tweak to that permissions functionality could yield a tremendous reduction in load. So slow queries are important for helping us see the things across the whole system in multiple places and how they affect our systems. Now, we've talked about these durations with performance, and all that's kind of complicated. Errors are really simple. They either happened or they didn't. It's true or false. You got one or you didn't. So errors are mostly just counts over a period of time. And we want to count them by the error class. We want to know how many of this kind of error we got. We want to know how many errors we got in this place. And then we can go and work on them. We just pick the one with the most errors and we fix it. Here's my advice on errors and error exception reporting tools. Please, for the love of God, don't ignore them. Handle them responsibly. It's very tempting to ignore them. But what we need to do is to find that level of understanding, dig into it, understand exactly what's going on, and then be able to act in a way that can resolve that problem. We talked about measuring our availability of our system based on a per request basis. 99.9% of the requests succeed. What happens to the 0.1%? They fail. I mean, by design, actually, this is kind of weird to think about, right? By design, we're planning on 0.1% of our requests failing. That's the bar that we've set for ourselves. So you can think of that as your error budget. And when you think of it in that way, it really helps with the guilt and the conflict that comes around quality versus features. Because on the one hand, the developer's like, oh, there's all these errors and I feel terrible about them. Product management, on the other hand, is like, there's all these features that our customers are asking for, and I feel terrible because I can't give them to them. An error budget gives us an objective way of looking at the errors that we have and deciding when to work on features and when to work on errors. When we first started recording this and keeping up with it, we was 150% over budget. Now this is what it looks like. And just by keeping up with that regularly and attacking anything that challenges the budget, we actually are now well below the budget. Now we can, in a guilt-free way, begin to work on the features that product management wants. Traces, in my opinion, are maybe the most valuable thing in APM tools and exception trackers. That's the superpower. The ability to actually look into what's running on our production servers, see what is happening, and figure out what the problem is, because now we can understand. Like on this one, it's pretty obvious, right? There's a big brown bar on the left side of this graph. That's probably the problem. It will show you each view that you're looking at, each partial, things like with controller methods. You can see each piece of that, timing for those. You can see the queries that ran in the context of that request. There's the one that made the big brown bar. That's where we should start. This is pretty easy, right? Once you understand, acting is a whole lot easier. When you didn't understand, you're like, I don't know what to do. This thing seems slow. Let's do something. Another thing that's important is alerting. When we think of alerting, we tend to think of just that text message, and our phone makes this sound, and we're like, oh my gosh, there was another text message from the site. I recommend thinking of alerting at 3 levels. The first level should be, maybe you should take a look at this and just put it like in a Slack channel, and you can look at it a few times a day, see if there's anything there that jumps out at you. If not, just ignore them. Create alerts that say, you should act on this pretty soon. And we have another Slack channel for that. Like, this is urgent. You probably should look at this as soon as you get a chance. And then the third level is you need to drop whatever you're doing and come and fix this problem right now. We're going to send everybody text messages. This allows the system. So instead of us having to watch things all the time, we allow the system to bring things to our attention. We allow the system to tell us, hey, you should do this pretty soon. And we allow the system to tell us, stop what you're doing and fix this problem right now. Alerts are very important, and we should just continually be developing them over time. Filters. We've got all these metrics now. We've got all these durations, we've got errors, we've got all this information, all this data. How can we make any sense of it? How can we look at it from a business perspective? How can we see it from the perspective of our customers? What we need to do is add in the ability to filter these metrics. And most all APM systems give us the ability to add custom metrics, custom attributes rather, to our events, to our requests and our jobs. Some of the ones that we've added to ours is, which customer is it? How big is this customer? Is it an enterprise customer, mid-market customer, small customer? Which user? Where did it come from? Did it come from our mobile app? Did it come from our users API, using our API? Did it come from our web app? Which squad is responsible for this? These allow us to then look at all the metrics in a way that makes sense to the business. We have in our support admin section the ability for our support people to look at a customer. There's a link there. They can click on that link. It takes them to a dashboard already filtered by that customer, and they can see the performance and the errors that that customer is having. So when they're talking to them on the phone, they can actually see what's going on. That's very valuable. Most of these systems will allow you to do that just by adding custom attributes and then filtering based on that. Another awesome one is filtering by squad. We just added that one recently. We're still in the process of getting it all worked out. But then squads can have their own dashboards, and they can take ownership of their own functionality and improve it over time, performance, errors, things of that sort, make it more reliable. Communication. Communication is very important when we're working on site reliability things because the stuff that we do is really hard for most people to visualize. Like when we go into dev demos, another developer writes some functionality, they demo it, everybody sees it, they go, awesome, that is so cool, I love what you did there. And I come in and I say, oh, well, I fixed this query, I added an index, now this thing hits the index with a complete index scan every time. I mean, it's just super awesome. And they're like, yeah, whatever. But you show them this, and they go, oh, I see the big brown thing on the left and the little brown thing on the right. You really improved the performance of this endpoint, right? So communicating is important. We need for everybody in the organization to be able to see the improvements that we're making. Graphs is a great way of doing that. Another great way of communicating all of this data that is so confusing and bewildering is to build dashboards that give people views into that data that are useful to them. We have performance dashboards, error dashboards, timeouts, site reliability that shows all the different snapshots of memory and everything on the system, load, all those kinds of things. An on-call troubleshooting dashboard where they can come in and really quickly see what may be the problem. We have dashboards around our SLOs. So this one here, you can see the squad table at the top. So each squad can come in and see how they rank compared to everybody else, and they can filter that dashboard by just their squad and see how all of their endpoints are performing. Here's one with accounts and users. This one is really awesome. You got an endpoint that is slow. You're not really sure why. You filter the dashboard by that endpoint. It shows you which accounts and which users are seeing the slowness. Then you can go in and say, what is different about this one compared to that one that makes theirs slow and theirs not? Very useful. Here's that troubleshooting dashboard I talked about. You see the bottom left, they've got thresholds on them, so it turns yellow when it goes above a certain threshold and then red when it goes above that. So you can easily see when there's a page what's causing problems. And then the last thing about communicating is that if we're going to build a reliable site, it takes a team. Site reliability engineer can't do it. Everybody is involved in that. So one of the things that we need to do is communicate to everybody else what's going on, how things work. So what we do is we have an internal blog, video blog and regular blog that we do in Slack. So we just do it in the team engineering channel. We just went low tech and just put some hashes in there. It gets a little weird with the channel panel thing, but it works. And then I'll do a blog post, which is all text, or I'll do a video post like this. I just do a screencast and show how to do things, how things work, and then that's communicated to the whole team, and we're all able to learn. In order to create a reliable site, we need to be continuously improving the visibility that we have into what's actually happening. We should, once we start down this path, I think it's wise to always have some sort of metric story in the backlog. I was trying to solve this thing and I couldn't. And if I could see this information, I'd be able to solve it. That goes in the backlog, right? Continually be adding those. Because to understand is hard. But once one understands, action is easy. Thank you.